Okay, next is about the homogeneous linear equations with constant coefficients. So we can write down the general form of the nth order homogeneous differential equation as equation 1 here, where, because it's like I said, it said that it's a constant coefficient. So a0, a1, until an is a real constant. It's not a function of x now, it's a constant. So with this equation, we can find n linear independent solutions to this equation. Let's say those solutions are y1, y2, y3 until yn. If we know that y1 to yn are linearly independent solutions, then we can write down a general solution for this equation into this form, which is yc is equal to c1 y1 plus c2 y2 plus c3 y3 and plus until cn yn, where c1, c2 until cn are constant. So how can we find y1 until yn? The way that we can find y1, y2 until yn, we can do this way. We assume that y is equal to exponential of mx. This is the way that we are going to find y1, y2 until yn. And then, because we assume that this y is the solution of this differential equation. So the way that we are going to find it, we can plug it in to our first equation. So if we want to put y equal to exponential of mx into our first equation, then what we got to do is just that we've got to do the derivative of this y for n times, right? So the first derivative of y is equal to what? We assume that y is equal to exponential of mx. M is a number. M is just a constant, just one number. So the first derivative of this y is equal to what? M times exponential of mx. So then what is the second derivative of this y? If the first derivative is m times exponential of mx, then the second derivative is what? M squared times exponential of mx. And the third derivative is m to the power 3 times exponential of mx. How about the fourth derivative? M to the power 4 times exponential of mx. So how about the order n? M to the power n times exponential of mx. So what are we going to do next? We are going to put y and its derivative back into our equation, our homogeneous, the n order homogeneous differential equation. So we plug it in, we would get this, right? The order n, we would get m to the power n times exponential of mx. But we have the constant value, the coefficient value is equal to a0 in front of the term of the n derivative of y by x. So we just plug our derivative form of y into the differential equation, so we would get this equation 2. So equation 2 here is there any function which is every term has? Any function which is every term in this second equation has? What is it? Exponential of mx. So I take the exponential of mx out. We would get equation 3. Now, in order to make the equation 3 to be right, to be true, either exponential of mx equal to 0 or the term inside the parenthesis equal to 0, right? But if exponential of mx is equal to 0, that doesn't make sense. That means you have the solution saying that y equal to 0. Y equal to 0 is not a useful solution. So this one couldn't be right. So in order to make this sentence to be right, in that case you have only one way out, which is the term in parentheses is equal to 0. So we just said that the term inside the parenthesis equal to 0, and we called it the auxiliary equation or characteristic equation. So with this equation, because you know that a0, a1 until an are constant, are real numbers. So you've got to find m. So in that case, how many value of m by this equation that you should be able to find? N value. So that n value would get you n answer, right? Right? Because you have y is equal to exponential of mx. You can find m, this m, for n value. So that means you have n terms of y. So that means what? That means that characteristic equation will lead you to find the n value of y. So then say that in that case, you can divide the answer of this equation into 4 different cases. Okay? The first case is we can find the n value of m to be a real root and it is an unrepeated. It's got to be the real root and unrepeated. Okay? That means the value of m got to be the real number and there is no same number in there. So we call it unrepeated real root. It said that if the root from that characteristic equation you can find as the m1, m2 until mn, so which is the n value, are real and unrepeated. This one you can say as unrepeated. Then the end solution of this differential equation are y1 is equal to exponential of m1x, y2 is equal to exponential of m2x, and then yn is also equal to exponential of mnx. They all are linear independent to each other. Then you can find the solution of this differential equation as yc is equal to c1 y1 plus c2 y2 plus c3 y3 and plus until cn yn.